This conference will now be recorded.
Good evening, everyone, and good morning. If you have joined from abroad, welcome to this workshop. This is Roshan. I'll be leading you to this workshop. This is a workshop on microservices, Docker, and containers. We'll try to understand the theoretical part in the beginning, and if time permits, we can also go over some practical demos on Docker and containers. So this is something about me. I have around 14 plus experience into IT, predominantly into performance engineering, Java and Python. I'm certified architect associate cloud professional, doing automation using various technologies, Java, Python, PL SQL, scripting, Selenium. Currently, I'm working as a principal SRE. Okay, so this will be the agenda of our discussion. We'll be looking into the monolithic overview. What do we mean by monolithic architecture? What is the advantages and disadvantages? And we'll understand by disadvantages that what option do we have? If not monolith, what option do we have? And then we understand the microservices architecture. We'll understand the architecture characteristics of microservice architecture, advantages, disadvantages, and things like. We'll understand where do we create these microservices, how do we host these microservices, do we have any place where we can host. So we'll talk about containers, because containers is where we host the microservices. We'll understand. So it is a very this workshop is from very scratch, and I'll be covering from very basics, so need not worry. If you have any questions in between, you can you comment it. I have in my second monitor, I can see your comments, and I can respond at the appropriate time. Okay. See, so coming to the monolith, so our understanding of monolith, does anyone understand what do we mean by monolith here? Just a very basic question to everyone out there. Do we exactly understand what is monolith? Anyone? Feel free to unmute and speak.
Single.
Huh?
So one, mono means one.
Okay, any other? Anyone else?
I mean,
okay,
we can deploy all the modules of the application in a single entity.
All the modules in a single entity. Very good answer. Yeah, that is the definition. Yeah, perfectly. Yeah, rightly put. Right. So monolith itself, the name means monolith, the big, which cannot be divided. That's the dictionary meaning of monolith. Okay. So self-contained, as I am noticing here, self-contained, packaged, and deployed as a single unit. So what happens in monolith, like let's say I have an application here, okay, and let me just use one thing here. Let me just use highlighter here. Okay, see, so currently let's say I have this application, a bookstore app, where I have multiple modules, let's say accounts, shipping, payments, inventory. Let's say it could be anything. Let's say imagine a Flipkart application, any retail application. So we must be having some login module, some module for the search, some module for the purchases, payment. So we have a lot of modules, right? So and all these modules are being written separately. First of all, the code, which you write the code, the functions. So consider the function. Let's say 10 functions are being written for the accounts, 10 functions are written for the shipping, functions for the payment, and let's say 10 functions for the inventory. Let's say any number of functions of these modules. When we deploy all the code in one place, let's say one application server, okay, that's the monolith. So we must be working on 3-tier application, right? So what is 3-tier application? One is your presentation layer, your web server where we host, right? And then we have application layer where all the business logic resides, right? And then we have a data layer, the database, right? So when in the application server, in the business logic, when all the module of your application resides together, means the functions are being called anywhere and everywhere. So if I'm writing a function for accounts module, F1 to F10, And let's say for shipping F11 to F20, I'm calling these functions anywhere and everywhere. If I need from the shipping module, if I need to call, let's say function F5 or F6 function number 6, which could have any name, I'm free to call, like how you can call in your inheritance, you call it, right? So you basically a function call, you can call these functions anywhere and everywhere. That kind of setup is called monolith, where all the business logic resides on the application server. These are embedded into one jar file. Let's say when you have the application, how this application, either you will have a jar file or a war file, right? And that's how you will deploy your application on the application server. Those jar files and war file will have everything in it and all together in it. You are not having separate jar files for different modules. For all the modules put together, you have only one jar file or a war file, and then you're deploying on the application server. So that kind of setup comes under the monolith application, where all the functions are being called anywhere and everywhere. So that kind of setup, it has a lot of disadvantages. Let's say advantages are few. What is advantage? Advantage is like you can deploy as a single unit perfectly. Yeah, you can have one jar file, because if you separate it, right? If you separate it and if you have, let's say, 5 jar files, so you'll have to deploy it separately. You'll have to run those jar files separately using Ant or Maven build tool we have, right? The developer thing. So once a developer writes the code, the code has to get built, right? So they use Ant. Ant is a tool, build tool, or Maven they use, right, to build, to inspect the code sanity, whether the code is working correctly or not, or it's failing somewhere. And then we deploy the code on the application server, and then you see what you see for any application, your code, the application logic, right? So if we break all these modules, which is the case of microservices, with that we will understand that if we break all these things and make it separate and independent, that comes under microservices. The monolith has one advantage, that all the code, since all the code resides in one jar file, I can deploy in one shot. I don't need to deploy it again and again. But if I have multiple jar files, which is the case of microservices, I have to deploy and manage separately. Obviously, the coding part would be separate, because why do we need microservices? First of all, because the greatest disadvantage what monolith has is one of the modules fails. Let's say accounts for one of the functions is not working, some bug in one of the functions. And if this particular let's say the problem with F8 function, one of the functions within accounts, and let's say F8 was called here in shipping or in payments, if F8 is not working, accounts is not working properly, and hence, because the functions was called multiple places in other modules as well, this module will also not work correctly, because there was one problem with one of the functions. So that's the problem with monolith, because even one failure module, one failure of the module, one module can impact your entire application. That is why we see, right, we tell, like, even for one bug, we cannot just manage forgetting that, or we cannot postpone that. For even simplest of the issue, if the entire application can halt and can be down, even for the smallest problem. But that's not the case with microservices, because we are going to make it separate, and that we'll understand that. So that's the definition of your monolith. So advantages, as I mentioned, single unit of deployment, perfect, and you have IDE support. You can use, let's say, if you're writing a Java code, you can write in, you can just take Eclipse and you can have all the things together, right? But there are a lot of disadvantages which leads to microservices, and nowadays all the companies, whether it's a startup or those who have monolith applications, so they're trying to break it up. They're trying to break the monolith application into microservices. And what is microservices? Just break down the same application, same modules, which earlier I had only one jar file, to where I had all the modules put all together. Now in the case of microservices, I'm going to make it separate and make this an independent accounts, shipping, payments, inventory. I'm going to make it separate. That is what the microservice is all about. So So the disadvantages of monolith, it could be often very large. Yes. Technology dependence on initial decision. Yes. If you have selected one particular technology to start with, let's say you started up with one module, let's say accounts or whatever reach. If you have selected Java or Node.js or Python or whatever JavaScript, you cannot change for other subsequent modules which you're going to develop in the future. You will have to stick to the same technology. And that's not the case with microservices. That's the greatest advantage again. So whatever the disadvantages you see in monolith, these are all the problems we're going to solve in microservices. Implemented using single development stack, as I mentioned. Frequent deployments are not practical. Yes, let's say I have found one bug. Can I deploy it? No, with one bug, we wait for a quarterly release. We wait for a quarter. We let all the bugs accumulate first, and then what we do, we deploy it all together. Frequent deployments are not practical and need to scale the entire application stack. Even let's say let's say assume this is a Flipkart application, and what do we exactly do? Most of the people do in Flipkart or any retail application like Amazon.com. What do we exactly do? We search for the functionality. The search functionality, search code is getting executed often. Any other
You're breaking up.
Functionality or module, right? So let's say I did a performance test, and I observed that is my voice breaking?
Yes,
Guys, you guys,
your voice is breaking. Yeah, I'm
yes,
also.
no, I need some answers from you.
Yes,
Yeah, now it
your
is
voice
fine.
Yes.
Okay.
Yes, it's breaking.
Okay. You are okay. Perfect. Thank you, guys. Thank you. Okay. It's breaking. Is it breaking or fine?
Now it's fine.
Now it's fine.
Okay. Let me know. Ping me. I'm seeing my chat, so I saw Mohammed ping. Okay, let me know, guys. Okay. See, so let's say I have one transaction. Let's say search functionality. Okay, and I'm seeing a higher response time because I know my search functionality is getting invoked multiple times, and there are more number of users which is accessing the search functionality. And let's say I have just one bottleneck with one of the transactions. Okay, one of the flow use case, I have higher response time. So what do I do now? In monolith, I will have to scale up the entire application server. I don't have any other option just because of one functionality. Higher response time observed with one of the use case, one of the transactions. I don't have any other option but to scale up the entire application server. You understand the cost of it, use cost. And just because of one functionality, it's not like I am resource constrained on other modules. No, I'm not. I'm just resource constrained in one of the modules, and I have to increase the application server compute size, the CPU, memory, RAM, or any other things as well, right? So that's not a good thing. I don't want, so that like a wastage. I don't want to scale the entire application stack just because of one transaction. And all these disadvantages, I'm going to fix it in the microservices architecture. I'm going to fix it. How can I fix it? We'll talk about that. We have a containers concept, Docker concept, and we'll understand how do we deploy microservices and how can we make things better, and how can we scale the application server. Just one of the module which is causing the problem, how can I scale that particular microservices or module? We're going to understand that in the case of microservices, and before that we need to understand where do we host these microservices and things like that. Okay, so coming to the microservices, as I have been pointed earlier, that what do we do? Creating smaller and multiple component services which are built to handle a very specific concern. So what I'm going to do, I'm going to break the same monolith application into multiple smaller pieces. Why am I breaking it? just to make our work easier. Okay, I don't want to have suffer the problem of because of one issue my entire application is down. I don't want that issue. Today you have Swiggy application, today you have Uber application. They are all built in using microservices. If I say you that if the Swiggy and Uber application would be built in Monolith, and let's say one of the notification is not working, let's say one of the notification small functionality that we have, when you book a cab or order a food, you get a notification that yes, it's been received, your order has been received, about to get delivered. Notification is not working. If I say you, if notification is not working, you cannot order your food or you cannot book a cab. How ridiculous it is, right? It is not good at all. So because if notification is not working, but still you are able to book your cab and order your food because it is based out of microservice architecture, because every component is separate. I'm not calling the function from one module to other module. I'm making it, I have made it independent. If one module is not working, it is not going to impact my other module. That's very straightforward in the case of microservices. So what I'm doing in microservices, I'm just trying to break my monolith application into microservices, and I'm making it a separate entity. And when I club all these microservices put together, they make up my application. That's what it does. So if you look at the architecture, this is how it looks. The architecture looks. So you have one API gateway. We'll talk about that in AWS or in any other cloud service provider, you have this API gateway where you can build your API. In the case of microservices, one microservices could be in Java. Other microservices need not be in Java. It could be in Python. I am technologically independent. I am free to select the technology which suits my requirement. Even if for the future, if I need to scale up my application, right? I want to ramp up my application, make my application bigger and global. I don't need to rely on the same technology which I have initially selected, which was the case of Monolith. So it was a huge problem that time. But now I have the flexibility to select the technology, the language, whatever suits my requirement. So in the case of microservices, one could be in Java, other could be in Python, other could be in Go language. I can use SQL and NoSQL both altogether, because since it's all about the different communication. So this particular microservices can communicate to SQL database, and other microservices can connect to my NoSQL databases. All this flexibility is possible because of microservices. And that is why the world, the IT is moving towards microservices. No more monolith application is going on, development is going on. The new startups, whoever is coming, is developing on microservices. And those who have already a monolith application, they are trying to break down their monolith application into microservices. I know you would have agreed, like some of you in this forum would agree that most of you would be working in microservices. Just one quick guess, how many of you are working in microservices? I want yes or no in the chat, just so that I get a fair idea about how things are going, and others can also see if you're working in microservices or monolith application. Feel free to ping, guys, so that I get a better idea about you. Yeah, I am getting, people are saying no. I got 2 no's. How about others? Okay. How about others? Okay, because okay, I think most of you are working in monolith applications still, where you are based out of 3-tier application. And okay, I got enough no, guys. Okay, but okay, I think that's the reason I think you guys are here, because you have been hearing a lot about microservices, and you understand now by just initial 10 minutes of discussion, you understand the importance of microservices and why this IT is moving towards microservices, because it makes our deployment, it is very important for application high availability also, because once I have microservices deployed in production, okay, you are working in web services, that's fine. Okay, okay, see, web services is a technology. I'm talking about microservices. It's a part of web services only. I'm trying to See, web services could be API. So that's, if you're trying to break down things, and if you're making a lot of API calls for all to connect to your microservices, that's what the microservices mean. You can still be monolith and you can use web services. That could be also the case. Okay, so it's not like if you're using web services you cannot be monolith. You can be monolith still being using web services. Okay, so so it's very important thing, okay, to understand this container technology, to understand this Kubernetes technology, because all these things are based out of microservices, not monolith. We don't talk of containers and Kubernetes and Jenkins, CI/CD pipelines, DevOps. When it comes to monolith, everything is related. All the things are related to microservices. That's the fact of the situation. Okay. So what do we exactly did in microservices? I made it autonomous. I made my microservices autonomous, and I made it for specialized. So when I was having with the dependency, okay, so in the first slide, all my modules were tightly coupled. All my modules were tightly coupled. Like I was calling the functions from one module to other, and everywhere I was calling it freely. I was not having any problem. They were deployed as a single tightly coupled one unit. In the case of monolith, what did I do? I just broke everything and I made it separate, and now these guys are autonomous and independent. I'm not going to call the function which I have written for the accounts module to the shipping module. I don't want to do that. If these accounts want to interact with the shipping module, I would expose some REST API. Okay, what actually I'm not saying you need to understand or develop the REST API. Just know that if the shipping module needs some data from accounts, what I would do, I would expose few REST API endpoints. We call it REST API endpoints. I will expose that, and then this guy would communicate to this guy over the REST API exposed endpoints. The same thing goes for other microservices. But I'm not going to call the functions from here to here. And I have tried my best to make it separate in such a way that I don't need to write the same code a lot more times. So let's say 10%, 20% of the code duplicacy is still fine. But if I'm thinking that if my code base is same for 50% or 60%, then I will not break these two applications. What I will do, because 50% of the code is same, why do I need two separate microservices? So I will club these two microservices, and I will put one microservices all together. So I need to separate also in such a way that there is not much of the code base, common code base, because that's the idea. I don't want to call the functions, account functions to shipping, but if there is any requirement where I need to have the same logic implemented in both the places, I will rewrite the code. It's not like I'm not going to write that. I'm going to rewrite the code because I cannot call this function from this guy. But if I call this again, this will be like independent. If I have issue with one guy here, it will impact the other module, which I don't want, right? If I don't want that, if I have issues with one of the notifications tab, one of the notification module, as I give you example in Swiggy or your Uber, I don't want that in the main application to go down. I want the main application still to be working. And I will also talk about, when it talks about containers, I will have replicas of the same containers. So I can have issue with one. You'll understand that part when I talk about containers and how this Kubernetes come into play. This is what you guys must be knowing, right? Kubernetes is so popular. Everyone is asking about Kubernetes nowadays. And we'll get to understand that why it is important. So what is the advantages of microservices? So flexible scaling. Yeah, I can scale this guy alone. If I observe that this particular or any particular functionality is requires more compute, more capacity, like more hardware, I can assign this guy because I am running it in microservices mode. These are independent, okay, and I can scale this guy flexibility because the way we deploy these microservices, we deploy in containers. Okay, so we have one VM concept. Okay, VM, you know, right? Virtual machines. In the same virtual machine, I'm going to containerize it, and I'm going to create containers, and then I'm going to deploy these microservices using Docker technology. Container engine, we'll talk about that. So I can do flexible scaling, easy to deploy because the code is simpler now. The if even if you have the bug in one of the microservices, the developer can look into that. I will have separate developer for different microservices. The work is also simpler now and defined properly. I can easy to deploy because I don't need to wait for the entire application stack to deploy. I can deploy the microservices independently. I don't have to deploy all together. A technological freedom. I can write one microservices in Java, other one in Python, other one in Go language. Reusable code. I can still reuse the code within the microservices. Within one microservices, I can still call the functions. If I am writing 100 functions, I can call 100 functions within this microservices. Within this module, I can call those functions. So it's not like I cannot reuse the code. And resilience. So that's the best part. Resilience is what the ability to be highly available. Okay, your application will be highly available because even if one of the modules is not working, it is not going to impact the other modules. Right? I gave you the example, the simplest example. If notification tab is not working, if notification is not working, it doesn't mean you cannot order your food or book your cab, right? So resilience, that's the advantages. And there are few disadvantages as well, but these disadvantages can be worked out. Okay. So spawning, like if you have too many microservices, how can you make it? So we need to all when we are, can you please, okay. See, reusable code, as I mentioned, right? So we can reuse the code. If I'm writing 100 functions for the account, within the accounts, I can call the functions, right? I don't need to write the function again and again. Within the module, I can call the functions, right? That is what I want, reusable code, right? But across the module, I cannot do that. I will have to, if there is the same code required, I will have to rewrite the code. Okay. But what I have done, I have separated these microservices in such a way that there is very less code common, very less common code across all these microservices, and that's what we need to do. Your your architect in the company, the big guys, right, who sit at the top, where they are deciding, they understand, they look at the code, and then they understand how can they make it, how can they convert from monolith to microservices, how can it make it better. They look at the code and understand. Your development manager would sit and decide on that, architect guys. So they look at that and then they decide how can you make this monolith application to microservices. So it has a lot of things to be discussed. All these disadvantages, your maintenance, if you have so many microservices, obviously you will have difficult to maintain. So you should not have many microservices, difficult to manage. Yeah, as I mentioned, if across the two microservices, I may need to duplicate the code. That comes under disadvantages. But again, the beauty lies in that you should segregate the microservices in such a way that you don't get the duplicate code, right? And network performance, we'll understand about that when we talk about the Kubernetes. And in Kubernetes, if we know how to deploy it properly, this disadvantage can also be worked out. Okay. So that's the difference, common difference, monolith and microservices. So you guys know about that. Next question. Okay, so any questions at this till this point of time, guys? Feel free to ask any question if you have. If you need more clarity on any of the things, please feel free. I am waiting. Yeah, you need any? Have you guys understood till this point of time? Can I get a quick acknowledgement? See, spawning is like if you have too many microservices. Okay, that will create a problem. Okay, so means too much of anything is called spawning. Okay, so you should not have too many microservices. That's what spawning means. So you want to break it down, break it up, but break it meaningfully. That is what. So these disadvantages are such which can be managed, if you do it well. But if you do not do it well, they are difficult to manage. Yeah. Okay. Are we good till this point of time? Can we discuss where do we host these microservices and what's the best way? Okay, I take silence that we are doing good. See, so there are three places we can host microservices. Okay, so the physical servers we can deploy, virtual servers we can deploy in containers. You know the VMs, right? So can anyone tell me what is the advantage? Let's forget about the containers now. I'll come to that. Can anyone tell me here what is the advantage of virtual servers over physical servers? Why do we need to break this big physical server into 10 VMs? What is the use of that? And this technology is called virtualization. Okay, and how it is useful? Because I think you guys are not working on microservices, that can be understood. But why do you need VMs? Why can't you deploy your server directly on the physical server? Anyone?
We can 100% utilize the physical server while implementing the virtualization server concept. We can break it one physical server, multiple segment. Each segment we can implement a single OS mission. We can make a single mission, like we can use it each segment as a single mission. We can reuse. We can use whole content of hard disk in multiple manner. You can 100% utilization happen at the hard disk level using virtual server virtualization concept implementing the physical server part.
Perfect. Absolutely right. Absolutely right. That is what I was looking for. This answer. Okay. Cost effectiveness and the efficient utilization. That is what VMs offer. What VMs offer in one line, we want to utilize this physical server efficiently. This is a big physical server, a lot of compute, lot of RAM. Why do I want to just host one application server or web server or database? That is the reason we virtualize, and when we virtualize this the hardware. Okay, and we install a hypervisor software, VMware software, or if you look at Oracle, there is a virtual box software. There are so many softwares out there. Just type virtualization software in Google, you would understand. There are so many things. Okay, out there in the market, and we install on top of that, and then we virtualize this, and we create VMs. And this is what the advantage is. That I want to efficiently utilize the resource, and this is what it does. I don't want to waste it. So what I will do to maximize its utilization, I would like to break this up into whatever VMs we have. And now I can, in one of the VM, I can have app server, in another VM, I can have web server, in other VM, I can have my database server running. I can do that. That's the best way. Coming to the containers. Why do we need containers? That anyone has, I know most of you are not working on microservices. Does anyone here know why do we need containers? And what are containers? Anyone knows here? I want you to just understand the crowd here, and then I'm going to take this forward. Deployment. Okay. Others? Anyone? Anyone? Okay. I think most of you are working in Monolith application. See, it is for the same region. Those answered why do we need VMs? The answer remained the same, to efficiently utilize the resource. What we eventually found out that even for the VM, we were not able to utilize the resource better. This process is called containerization, and most of us are since not working in containers and microservices. I can definitely say you guys are not working in Docker, containers, and Kubernetes as well, because this is the starting point for those things, right? So when the goal is still the same, because the goal of the virtualization was to efficiently utilize the resource, right? The is still the same for containers. What I'm going to do, I will take one and I'm going to break that VM. I'm not going to break that. I'm going to deploy multiple containers on that VM. This is what I'm going to do. Voice breaking. Sai Kumar mentions, is my voice breaking? Others can confirm that, please. Is my voice breaking, guys? Okay. Mohammed also is the same way. Now it is fine or still breaking? Can I continue or do I?
No, sometimes in the middle of your explanation, so some words are blurring and not clear.
Okay. Okay, maybe my mic is not currently. I'm just holding my mic now in my hand. Okay, can you guys hear me fine now? Is it fine now?
Just
currently, right now?
Yes, it is fine.
Blurring.
Okay.
Yes.
Okay, perfect. I'm gonna do the same way. I'm gonna hold my mic in one of the hand and I'm gonna repeat this. Okay. See, so it is for the same region. Okay. Those guys who answered why do we need virtualization? It is for the same region. We need this containerization. This concept is called containerization. Okay. Virtual servers to containers, right? So what I'm going to do, I'm not going to break it up here. Okay, I'm not going to make it separate containers from one VM. No, I will take one VM and I'm going to create multiple containers in that one. So just think like that. I'm trying to make you guys understand. Let's say you using a 3-tier application. Let's say one is web server, one is app server, one is database server. So you needed 3 VMs, right, to deploy your application, to make it running 3-tier application. Okay. So now what I'm offering you, if you containerize it, if you install a container engine like Docker in one of the VMs, you can create multiple containers. And what you can do by one container, multiple containers. So in the same VM, you can have 3 containers now. In one container, you can have web server, another container, you can have app server, and in the third container, you can have your database server. So the idea is still the same. I want to efficiently utilize the resource. The idea has not changed. The intention has not changed. I'm still looking for the efficient utilize of the resources. I'm still looking for that only. I'm not doing anything else. So, and when I'm exhausted with one of the VMs, I agree that that particular 3 container setup will not handle that much of load. That's fine, totally fine. I don't expect that. But if I need an additional node, additional VM, node means VM. If I need an additional node or additional VM, I will have it, and I will also do the same thing there. I will have a web server, app server, database server again in that VM all again. So in that case, my application is up and running, and I'm able to save on the resources as well. And the containers are best to run the microservices, right? So I hope everyone has understand the containers. So this is how it looks. Okay, so in the VM, I have a big infrastructure. I have installed one hypervisor software, and I created 3 VMs: VM1, VM2, VM3. I needed separate operating system for all my VMs. That is again a problem. In the case of if I just talk about, if I don't talk about in the context of containerization, I still have the problem, because in the case of containers, I don't need separate OS. But you guys know that if you are working in different VMs, you need separate operating system. Okay, guys, VM1 needs separate operating system, VM2 needs separate operating system, VM3 needs separate operating system. But in the case of containers, because when I have one, so I'm showing you one VM here, okay? In this complete thing on the right side, I'm showing you one VM. And what I'm going to do, I'm going to install a container engine, okay? So Docker happens to be the one container engine, okay? Docker is one example of container engine. There are other container engines out there as well. Docker is the one of the container engine. So what it does, that it allows to create multiple containers on the same VM. So I have this physical server, I have the host operating system. On top of that, I'm going to install a container engine. That container engine is going to be my, okay, and I'm going to create containers, multiple containers. So now where I required 3 VMs to have my 3-tier application, in the same VM itself, I can have 3 containers. One container will be have my web server, another container will be my app server, and another container will be my database server. So the intention, the idea is still the same. Utilize the resource. That has not changed. Want to efficiently use, and that is not going to be the change. That when you and the Kubernetes is like, okay, voice breaking again. It is okay. It is for everyone, guys. I don't know why today I'm facing this. Can you hear me fine or no? Breaking again.
No, it's a few minutes back it was breaking.
Yeah, when you're expanding some concept,
Now
right?
it's better. It's audible.
Yes. Yeah.
Yeah. Okay. I don't know what's happening, guys. I don't know. Okay. Let me. Okay. See. So okay. Let me continue. Okay. I hope you could understand, right? Because I'm repeating it, so I think you can understand. So now, where I require 3 VMs to have my my web server, app server, database server. Now I can manage that in 3 containers, and that too with one VM itself. One VM itself, right? So that is the part of containers, and containers offers a lot of advantages. A lot of advantages over. It will boot up in second. Okay, it will boot up very fast. It's going to be take very less, what to say, the footprint is going to be the very less, it's going to take very less CPU memory. And the best part is that unless I'm not going to fully utilize the one VM, I'm not going to use the other VM. So to get the efficient utilization, the maximum utilization from one VM, I have this technology called containers. And if you move forward in containers history, we have Kubernetes. Okay, we have Kubernetes, and what say when they use Kubernetes, they were able to reduce 50 to 60% of their cost because everywhere they're using containers concept. Containers everywhere, containers. And when you run it containers, and because it does the efficient utilization of the resources, and when you look at for the year, for a long term, it has huge impact on the cost. And what everyone is claiming that they were able to reduce 50 to 60% of the cost using container technology, right? Portability, resource efficiency, that's the best part, right? Resource efficiency, that is what I'm looking for. That's the main advantage. Isolation, speed, and scaling. I can scale up independently because I have, if I know my web server, okay, if my microservices, one of the microservices needs more compute, I can provide that. I can give more compute to one of the microservices. That. So if I talk about the containers, okay, so we have 2 popular containers, Docker and Rocket. We are going to look into the Docker now, okay, and this is what the difference, the VM and the container concept. The best part, still I think you missed out. In the case of VMs, I need a separate operating system. Separate operating system. But in the case of containers, I don't need it. You can just see that I just need the host operating system. And what this container engine does, it virtualizes the host operating system. This is what it does. That is why you don't need a separate operating system, and it works perfectly with Linux, not with Windows. Remember that. It will not work. The containers will not work with Windows. If you have an application where Windows are required, like if you're doing some C# programming or where Windows operating system is required, this particular thing has not been worked out. So, but most of us are working in Linux, right, where the application server is deployed in Linux, right? Most of database is in Linux, web server in Linux, and that's where this container technology works perfectly with the Linux operating system, right? So that is what it is. Okay. Any questions as of now, guys? Are we doing good? Yeah. Okay,
I
I
have
have
one
been getting.
question.
Yeah, please go ahead. Yeah.
Why they are not implemented Windows OS part?
No, this Windows. It doesn't work. Okay, it doesn't work. It doesn't scale that well. Windows is having licensing issue as well. It doesn't work well with Windows. So that's the development, IT development I'm talking about in general. So containers do not go with Windows. So, but most of the applications, whatever I have worked on personally, I know that we deploy on Linux operating system. Licensing part is also there, and Windows is heavier than Linux, Unix, right? Not that possible. Any other questions, guys?
I
I have one question.
Yeah, go ahead. Yeah.
Yeah, so it is related to the previous slide. In that you mentioned containers can run within VMs. So is it like we can run containers separately and with the VM also, or in the VM only?
What was your first part? We run containers in the VMs. So see, I gave you option. You can run containers on the physical servers. You can run containers on the virtual servers. Okay. You need hardware, right? Containers are not the hardware. These are two hardwares. We have understood that why we need virtualization. We understood that cost effectiveness, efficient utilization. We are in the VMs now. So we run containers on the VMs so that we get the advantages of the VMs, whatever we have, the maturity and the stability what VMs provide. And we run containers on the VM. So basically, you can understand like a process. Containers are nothing but a process. I'm not going to break down the VMs, how it happened during the physical servers to VMs, right? I'm not going to break down the VMs and make it and this particular section for this container, this particular section for this container. No, I'm going to run multiple containers on one VM, like a process. You understood? I hope I answered the question.
Yeah, got it. Thank you.
Yeah. Sure. See, I'm going to show you guys. Okay, so this is the AWS console I have. So I have one instance. When I create this instance, let's say workshop, I have named it. So this is my one VM. They have already done the virtualization. You know, the AWS guys have already done the virtualization, and I created one instance in this. This is one VM. Okay, with 1 GB of RAM and 1 vCPU. Okay, let me just show you. This is the VM I'm connected to. Okay, so this is the VM. Let me just make it more readable format. Okay, let me just. Okay, I hope you guys can see this well now, right? So let me be root user. Okay, and this guy is having only 1 vCPU and 1 GB RAM. Okay, so 1 vCPU is there, and RAM is also 1 GB. Okay, so I'm just using the free tier from AWS, nothing else. So AWS is a cloud service provider. I have used it. So currently there is. Let me just update this operating system. I just provisioned this VM. So this is the Ubuntu operating system. Okay, I have used Ubuntu operating system here, and I'm just updating the operating system. How do you do Windows update? I'm doing the same thing here for the Linux. So what I'm going to do here, I'm going to install a container engine like Docker. Okay, very simple. There's a long process also to install Docker, but the easiest install is to do apt, because I'm already a root user. I can simply type apt install docker io. So this is a container engine. Docker is a container engine. Okay, and I'm installing it. And now, so just remember this diagram. Okay, the one I explained before. So I'm installing. So this was the VM I'm using a Ubuntu operating system. Okay, I could have provisioned a Red Hat also. That's perfectly fine. I have multiple options. That's under the AWS. I have a lot of options. I selected Ubuntu, and I'm installing a container engine which is named Docker. Okay, and then I can create multiple containers here. So I'm going to show you how can I run multiple containers. So Docker is getting installed. I'm going to check the Docker version now. And the way Docker works, like, I think you guys have not heard of Docker because you not worked on Docker containers, right? So Docker is a company. Docker Inc. is the company which provides microservices images, container images. These container images are nothing but the microservices. When you work in services, this is what you do. You store the images, microservices in the form of containers. So Docker Inc. is a company which provides you the container images. Okay. So I'm going to take, so let me just introduce you to one site, docker.inc, docker hub.docker.com. Okay, you can just type hub.docker.com. I'm going typing it in one of my second laptop. I'm showing you here. So if you type hub.docker.com, you will get this website. Okay, and what these guys have images. So let's say you use Tomcat, right? As a as an application server, you use, right, Tomcat. So you have an image for Tomcat. So this is from official image. Tomcat has published this. So if you want this image, you can do docker pull.tomcat. Once you have Docker installed, you can pull this. If you want MySQL is a database, right? So you can also pull this image and you can run it as a container. For web server, you have HTTPD. This is a web server from Apache, right? So it's a web server. So I showed you one app server, one web server. There are so many images out there. From MongoDB also you can find. There's so many stuff here. You can find it. Okay, Mongo. So MongoDB has this. So let me just check. So what I'm going to do, I'm going to, okay, this is taking time. Okay, I'm going to check the Docker version quickly here, and I'm going to. Okay. Meanwhile, if you have any questions, feel free to ask. And if not, I'm going to also introduce you. If you're looking for the complete course about, I have been using AWS, Linux, I'm also using. I'm talking about containers, microservices, Kubernetes, Jenkins. If you're looking for all these things, I have this course coming up. Okay, course coming up. We are starting up tomorrow. My demo is on tomorrow, 9 p.m. IST Indian time. You can find other details about the course content, the syllabus here. You can find the course. I'll be talking about cloud computing, AWS, Linux. If someone is new to Linux, not able to understand Linux command, I'm covering that as well. And everything is from scratch. Monolith, MicroServices architecture, container, Docker in detail, I'll be talking about, followed by Kubernetes and Jenkins, a lot more DevOps and Jenkins, and how do you continuous performance testing in
Course?
no, only one course with all the
sections, but the timing changes,
again?
right? The one you share
timing changes.
or the time is gonna be tomorrow 9 instead of 8, right?
not instead of 8, it will be 9 p.m. IST. You can convert in your time zone. It is going to be 9 p.m. IST. Today's session was from 7 p.m. IST. Tomorrow it will be 9 p.m. demo. You can join me on for. Yeah.
My question here is are we talking about the same course, or is it going to be separate, or this is the same section we attended tomorrow, right?
Correct. Tomorrow is going to be the demo about this particular training. Today it's the workshop we are going about. Okay. Today we are discussing the content on the microservices, Docker, and tomorrow is going to be my demo for the entire course. What are going to be covering? I'm going to cover in this entire course. So if you're interested, looking for such course material, you can join in tomorrow, dial in tomorrow at 9 p.m. IST. Okay. So let me check my. Okay, still taking time. Okay, 98%. Just okay. Okay. So my Docker is getting installed. Yeah, for sure my network is slow today, but I don't take this much time to install Docker. What I'm going to show you currently, I'm going to show you that how can we create containers on one VM. That's what I'm going to show you in the upcoming 5 to 10 minutes. Once, because Docker has to be installed, the container engine. Remember this diagram, okay? This particular diagram. I'm just, what I'm doing, I'm installing a container engine. The name of the container engine is Docker. I could have installed Rocket. I could have installed Containerd. There are a lot of container engine out there in the market. I have taken one VM, Ubuntu operating system in it. I have installed Docker, and I'm going to create containers. And the images, I'm going to take it from the hub.docker.com, the one I showed you. I'm going to take the images from here. I'm going to run it, and I'm going to show you. That's what I'm going to do. Okay, so my Docker is running, is installed now. I can do quickly Docker version. Yeah, perfectly. I have my Docker version. So Docker is having both client and server. So I have my Docker version installed. What I can do now, I can quickly run one image, okay? And I'm going to execute one image here. Let me just take HTTPD. It's a web server, okay? HTTPD is the web server, and what I can do here, I can just do Docker run. I can do first of all Docker pull, okay? I can do it separately also. So let me just go back so that everyone understands what I'm going to do. I'm going to download this. So by default, what happens? Docker and interacts with hub.docker.com. You can also create your own repository, and you can have your own image also. Okay. So what happens that if I issue this command docker pull, okay, this is not the official image. I want the official image. Okay, this is the official image. If I do docker pull HTTPD, okay, it is going to download the. See, if I type docker images now, okay, let me just docker images now. There is no images as of now. You can see there is no image right now. So what I'm going to do, I'm going to issue that command docker pull HTTPD. What it will do, it will connect to the hub.docker.com, and it's going to pull that HTTPD image, container image. Okay. So if I do Docker images now, you should see one image. This is a web server. I can host a web server, you know. So I need to show you that I can host a web server. So what I can do, I need to run it. So Docker PS, so they are the commands. So don't worry, they are very basic commands that we use to check if there is any running container, because just I installed Docker, so obviously there is no container running. So there is no container running in Docker PS. Docker PS is the command which will give you the list of all the running containers. Okay, so let me run this docker run. And what I do, -it is the interactive mode, -d is the daemon mode. I want to run it, right? I want to do -p as well. I want to do port mapping because I'm going to it's a web server, so I need to port map, right? So 83 port of my, I know that this particular container, this particular container image runs on port 80. So I need to point it somewhere on my host, right? So 83 port on my host maps to 80 port of this container, okay? And finally, I need to give this image name. So what I'm going to do, this is the standard set of command that I'm going to do. Docker run is to execute a particular image, and this is going to make me a container. -it, -d, daemon mode, IT is for the interactive mode, P is for the port mapping. Basically, what I'm saying, I can, once I run this, I will get a web server, and I can access this web server on port 83. So let me run this quickly. I got one container, Docker PS. I have got one container. It's a web server, and it's running on port 83. I can prove it to you that it is running on 83 port, 83. This container by default runs on port 80.
Currently confusing.
Web server. Hello.
Yeah, it's currently confusing the way you're going, right?
Confused? Please, can you come again? What's the confusion?
Can you look into the chat, please? Because people are sending messages.
Dave has sent me a message. What does 83 stand for?
No, it's clear for me now.
Please.
I think it's clear. Yeah.
Does anyone have any confusion? I am explaining it the simplest as I can give. 83.
The downloading the stuff, everything is confusing to me. I don't know for all that.
Everyone is, I think everyone is, see, let's keep it simple. What I'm going to do, I have just downloaded this image from hub.docker.com. Very simple. When I install Docker, I don't have any images. I just pulled this image, nothing else I did. I just pulled this image from hub.docker.com. That's all I did. Now you have the image with you. Now what will you do with this image? You want to make it a container, right? So you need to run it. So that's the second step. I am doing it. I'm running this image, and this is the web server. I need to point this. I need to do a port mapping. -p stands for port mapping. This container runs on port 80 by default. So I am making it a place where I can host in my container as well, because I need to connect to this particular container, which I've just created. So you can connect to this container on port 83. I'm going to show you now that you can connect to it. I'm not sure how it is confusing, guys. So let me just do one thing now. Yeah, perfect. Okay. So what I can do now, I need to do one thing before that. I was using AWS console, okay, and I need to open one. There is a section called security group. Okay. I need to open port 83. Before I do not open port 83, no one can access my VM, because what I have done on this VM, I have installed this container. And what I'm saying, 83 port is enabled. I can access my web server on this particular VM. So I need to open this port here, 83. So what I can do now, I need to go to the security group. I need to open port 83 if it is not open. Okay. First of all, I need to check which security group I have used. So let me go back to my instance, and let me just check it on the which security group I have used. What is the name of this is the name of security group, launch wizard 1. Okay, that's my security group I have used for my VM. Okay, now what I need to do, I need to edit the inbound rule, and I need to open port 83. That is what I need to do. If I do not open it, I'm going to show you before me enabling it that I cannot access this guy. Okay, let me not. I have not edited, guys. Okay, so I'm going to show you what impact it will have. I'm going to take the public IP of this my EC2 instance. Okay, that's the public IP, and my port, my web server is on 83. So like host IP and port, right? It's not working because 83 port have not opened it as of now. So as soon as I will open it, I will go to the security and I will go to my security group. And as soon as I will open port 83, it's going to work. And let me make it all. So everyone can access, even you guys can access it. I have saved the rule and I'm gonna come here, I'm gonna refresh it. This is the web server. It is accessible. Even you guys can access this. This is the public IP of my, sorry. So this is the public IP. Let me check this. This is the public IP, and that's the port 83. It will be you. Even you guys can access it. I'm gonna send in the chat. Let me know if you can access this. I just hosted a web server in my instance, EC2 instance, in my VM. Can everyone can access this? Yes. Yes. So this is one of the containers I created, guys. Okay. I'm just going step by step. If things are overwhelming, you can watch the video. I'm going step by step as I can get. Okay. So if I do Docker PS now, I just have one container. Similarly, I can have other container also. I can have my web server. I got it. I can have my database, MySQL. I can have my application server also. I can have a 3-tier, 3 containers having all those features what I was having with 3 VMs. I could manage in one VM only with 3 containers in it. So what I'm doing, what I'm achieving, efficient utilization of the resource. That's all I'm doing it. That's all I'm doing. And it's so fast. I can stop it, just flash of a time. In just Docker stop, if I just do Docker stop, you see the container, done, stopped. Container is stopped now. I'm just waiting for my thing to come up. It's going to stop now. Docker PS, if I do, it's gone. No container. It boots up in seconds. Now you can access it. You will not be able to access my page, the web page, because the container is gone now. You cannot access that page. If I want that page again, I need to run this command. Now you can access it. It just boots up in seconds and it stops it takes very fraction of time. How much space it has taken, how much footprint to type Docker stats. This is the amount of footprint it's taking because I'm not running anything, and that's just the memory it is consuming. Out of 1 GB memory that I had, it is just taking 6.32, nothing else. Because I'm not doing anything, you can understand how much it is taking. Even if you do a load test, if 100 people are accessing my web page, it will just spike to something. We can understand there is a command called Docker stats. Similarly, you can have your containers up and running. So that's all I wanted to cover today, guys. Okay, that's all I wanted to cover. And you can stop it and you can stop the container. There are a lot of operations out there. You can find if you're looking for other details, you can find a lot of commands there is a docs.docker.com. There is a link, docs.docker.com, and you can find a lot of commands. Okay, manuals are there. You can find a lot of commands to work with Docker. I just used very simple commands to start and stop. There are a lot of commands you can use it. Let me just search for Docker PS.
So Docker cannot use for Windows, right? You mean to say?
No. Docker cannot. No. But Docker images you will not find because you cannot create containers there. Okay, so that's. So you can find a lot of commands here. Okay, there are so many commands are there. I just showed you one command. You can just have a list of all the commands here in the Docker CLI, and you can just make use of Docker app attach. There are so many things you can play. Docker CP to copy something difference, it will give you difference. So there are so many things out there. So if you are looking for an extensive course, you can join me tomorrow to get a demo. And this is the course I'll be covering AWS. I'll be covering AWS. If you're new to AWS, I'll be covering from scratch. Linux, if you're new to Linux, I'm going to cover scratch microservices, Docker, Kubernetes. I'm going to talk about EKS, Elastic Kubernetes Service. That's AWS thing, Jenkins and CI/CD pipeline, and continuous performance testing in DevOps. How do
I
we
have
use
a doubt in that
Jenkins?
part.
Yeah.
So under microservices part, are you going to be how to implement the microservice in I think programming level, either how to host the microservice in component level, like
Host. What is microservices? I have told you today, but I have just introduced Docker. There are plethora of knowledge is there in Kubernetes. People use Kubernetes nowadays to host their microservice application. Kubernetes is from Google. Google is running Kubernetes from 1 decade now, and that is why Google is so good at scaling. You will not have any application which having more load than Google, right? Google has been doing a splendid job in the performance and catering to the user requirement needs, right? So, and they have been using Kubernetes. Kubernetes from Google. So a microservice is the foundation of that, and Kubernetes is what people use to host the microservices. Docker is just a container engine to create it, but you need an orchestration engine to manage containers, like auto scaling. If load is increasing, auto scaling, scale up, scale down, auto deployment. There are so many things, blue-green deployment. There are so many things out there to understand Kubernetes. So yeah. If you're looking for such a course, I have given you the link. I'm going to be patient
Will you
again.
be
If you're looking for
developing
this,
microservices?
yeah, microservices.
Will you be
covering.
will you be developing microservices using any
Not developing. It's not a development course. No, it's not a development course. It is the course for the performance engineers and DevOps engineers. I'll be talking about microservices, how to deploy it, how to work with microservices.
So, like, would you be giving some?
But know how to create it.
So do one thing. This was a workshop. I just got to discuss something with you. Tomorrow you can like come back and join the session, and we'll discuss about that. You can ask the questions related to this tomorrow, 9 p.m. IST. So I'm done with my workshop for today. If you have any questions on the workshop, please let me know for today. I'll keep my discussion very much relevant to for the workshop. You guys are okay with the concepts I discussed today? You understood, you learned something?
yeah.
Yeah.
Okay.
I'm sorry. Yeah. It was helpful, but I just have a question. I'm a performance tester myself, and
Okay.
from a performance engineering perspective, right? I mean, how are you going to help us out with a real life performance engineering concept without tools like Dynatrace or AppDynamics or something like that, right? I mean, with this course, how are we going to troubleshoot you got what I'm saying?
Okay, I understood, because I come from a similar background, so I understand your question. See, from a performance engineer or tester like you, when you talk about performance engineering, yes, you have Java performance engineering where you do all sorts of troubleshooting like heap dump or thread dump, or in the database if you're working on Oracle database, you look for Oracle database AWR report and ASH reports and things like that to troubleshoot and understand where is the issue, right? So that's about performance engineering. What I'm offering here is a transition, because what I have heard from this particular forum that not many of you were working in microservices and containers and Kubernetes. If today, if tomorrow, if you're gonna be working in microservices, those engineering part is gonna be the same. The application is still going to be the Java, right? You're gonna be just doing the same thing. Java performance engineering is not going to change at all. The only thing, how you take a dump would be different, or how do you look at the logs would be the same. All those engineering part is going to be the same. I'm going to tell you that what AWS has to offer you on the monitoring part. You mentioned about Dynatrace, AppDynamics. Those are APM tools. AWS, if you, let's say tomorrow, if your application is deployed in AWS, what all will you monitor? Can you monitor host level data, right? See, APM information is good at the process level. What you have, let's say you have, you're working in an application where deployed in AWS. Will you be able to use Dynatrace or AppDynamics? Do you think would the company would be sponsoring The company may or may not, but what AWS has to offer, I will tell you. In AWS, to get started, how do you work on VPC? How do you working on networking? How do you do auto scaling? Because see, we are come to the cloud. Here the auto scaling happens. I don't need unlimited servers already configured in my production. If I need servers, I will get it on demand. That's called auto scaling. I will tell you how to do auto scaling. That's very much relevant to performance engineering. How do you do troubleshooting of Kubernetes? Unless you do not know the basics of Kubernetes, how things are get deployed, where to look for logs, where will you troubleshoot it? Right. So I'm gonna cover that as here,
So
where the people who are very much new to microservices and cloud world, this particular course is designed in that perspective. If you're looking for other engineering courses, we have other engineering courses as well. Isha has it. You can contact Mr. Kumar. Yeah.
Okay, so basically it is manually looking into situations as opposed to a tool that is being provided, correct? Yeah, that's what you're going to help us out with.
If your application is deployed in cloud, your application is microservices based, working in Kubernetes, how to get started, what to do, I'm going to help you there through this course.
Okay. Okay. So
if I
join
tomorrow for more details, you can join tomorrow.
Okay.
Okay. So thank you everyone for joining. We'll connect tomorrow. Yeah. Thank you.
Thank you.